Okay, let's go ahead and start chapter 1, section 6, which covers exponents and a little bit of order of operations. So the first part right here, understanding exponents, we kind of go through the parts of a power. Okay, that's 4 to the third power. That the whole thing is called a power. All right. Now the bottom number, the big number at the bottom, that's called the base. All right. So 4 is the base, and obviously 3 is the exponent. All right. Now a little bit of notes here. So the blank provides how many times, well, the exponent, let me just write this down. The exponent tells us or provides us how many times the base, in this case it's a 4, should be multiplied by itself. Okay, so what that's basically saying is this is 4 times 4 times 4, which is not 12, right? Not 12. 4 plus 4 plus 4 is 12, but 4 times 4 is, if we just break this down, 4 times 4 is 16, and 16 times 4 is 64. Okay, so it's not the same as like 4 times 3. It may seem like that, especially when you're dealing with the number 2, because like 2 squared is that's one example where, like, if you mistake multiplying it and kind of the power part, you get the same answer because it kind of works that way. But that's it. All right, now this next part right here, writing in exponent form, we just got to be able to write, like right here, for example, A, we have a bunch of 8s. How many 8s do we have? What do we have? We have 3. I'm gonna count my 3s for some reason. Oh, that's a good idea. 3, 6, 9. Right there, I got 3. So that's gonna be G to the 9th power. G to the 9th power. Right here, we've got, what do we got? 6 5s. We got 6 5s, right? We got 3 and 3. All right, and so that's going to be 5 to the 6th power, and then we have 2 n's. So times n squared, just like that. Okay. All right, and that's all we're doing. Just kind of just writing this out. Right, what we're doing right here, it says write in exponent form. Another way to put that would be is just writing it in exponential form. All right, so for example C, we've got x to the 4th power. X to the 4th power. Oh, I should write it like this. Times, well, it doesn't matter. Times 2 to the 3rd. A lot of times we put the exponent, or we put the variable term after the number, but you can write like this. It doesn't really matter for this one though, because this is just an exercise and just writing it out as an exponent. All right, so this one's, for example D, it's all mixed up. So how many 6s do we have? We have 1, we have a couple here, we have a 6 there, that's 4 6s. So I'm gonna write 6 to the 4th power. How many h's do we have? Well, we have 3 h's here, an h, an h. So that's 5, right? So we have h to the 5th. So 6 to the 4th, h to the 5th. Don't worry about multiplying them out on that one. We're just kind of just writing them out as an exponent. All right. For this next part right here, we're expanding it. Okay. So so what does m to the 6 mean? Well, it means m times m times m 6 times. That's what that is. All right. So we've got right here for B, we got 3 to the 3rd power. That means 3 times 3 times 3, which is 27. But we don't really have to worry about that. We're just writing it out in expanded form. All right. Now for this one right here, we want to actually work it out. So 2 to the 5th power means, let's expand it first. That means 2 times 2 times 2 times 2 times 2. All right. Which is not 10, right? So 2 times 2, that's 4. I can kind of do this. I can break it up. That's 4. So I have 4 times 4, 10, and I'll drop down this 2. All right, and I can just kind of break this up. 4 times 4 is 16, and then 16 times 2, just drop that down again, is 32. So 2 to the 5th power is 32. And then 1 to the 7th power. It seems like it should be 7, right? But it's not, right? And the perfect way to kind of debunk that is just expand it, right? 1 times 1 times 1, 7 times. Yeah, 1, 2, 3, 4, 5, 6, 7. And 1 times 1, guess what? 1 times 1 is, oops, I erased it. But 1 times 1 is 1. This is 1. That's 1. Everything times 1. Anything times 1 is going to be 1 or itself. In this case, all we're doing is multiplying 1. So the answer is just 1. All right. So anytime you have a base of 1 and any power, it could be to the 93rd power. Guess what that is? It's still 1. All right. Okay, translating the language. This is kind of easy. Just kind of just a little reminder here about sometimes it's not always to the second power. Sometimes it's recited as squared. So 8 squared just means 8 to the power of 2, right? 8 squared is another way to say squared is 2, right? To the second power. And then another one too, another thing you might hear a lot with exponents is cubed. That's a very specific kind of exponent. That is to the third power. So that's 12 to the third power. All right. A number raised to the fifth power. Well, we're not sure what that is, but a number, so we'll just say n, and we'll put to the power of 5 right there. N to the fifth power. Now we're not sure what that is because we have to know what n is. N is a number. It's some number. It's a variable in this case. We're not sure what it is. Okay, now let's go through order of operations. Okay, so order of operations is a little bit complicated. Now I wrote down the PEMDAS acronym or across. I don't know if that's a initialism. I don't know what that's called. I think that's an acronym. Mnemonic, sometimes it's called. But anyway, PEMDAS is great. Now the P for for this, the P stands for parentheses. And the order of operations, you want to do anything in parentheses. However, I got to make sure this is said. Sometimes this acronym, this PEMDAS acronym, gets a little bit of pushback because it's not always the most accurate. All right, because it makes it sound like, well, if there's no, because all we think of parentheses, and if we see something else besides parentheses, then we don't do it. But parentheses, it could be any grouping symbol. Not just, parentheses are one type of grouping symbol, but it could be any type of grouping symbol. So parentheses, of course, are easy to spot, because we know what those look like, but there could be brackets. That's a type of grouping symbol. You could have these things right here, these little squiggly things. Those are called braces. Right there, those are called braces. You got that. You could have a fraction, where you have a numerator and denominator. A fraction is a grouping symbol because it's grouping the top and the bottom number, because you might have a math problem in the top and you might have a math problem in the bottom, and that's a way of grouping it. What else is a grouping symbol? Absolute value, like doing the absolute value of like x minus 3 or something like that. Radicals, you might have something underneath a radical that you need to solve. So any type of grouping symbol, I might have missed one, I think, but I think I went over the most common. All right, but parentheses, and the thing about order of operations, parentheses aren't really an operation. They're just like I just stated, they're a grouping symbol. They're just a way of kind of organizing the problem, which tells us, hey, do that part of the problem first. Okay, sometimes you might have we're not really going to get that complicated yet this early in the curriculum, but sometimes you have grouping symbols within grouping symbols. And if that happens, do the innermost part, the innermost grouping symbol first, and then kind of work your way out from the inner to the outer part. All right. But like I said, you're not going to have that yet. All right. But parentheses aren't really an operation. They're just a way of kind of organizing the problem, telling you to do that first. The next thing is exponents. The E stands for exponents. Okay, there's no mystery about what exponents look like. Any type of exponents you want to do first. All right, and then the M and the D. Now let's kind of talk about that. Yeah, multiplication. And in this acronym, multiplication comes first, and then division comes second, which confuses us. That can be confusing because multiplication doesn't necessarily come before division, and division doesn't necessarily come before multiplication. All right, so maybe you know this, maybe you didn't, but it's very important that you know this. But when multiplication and division are together, It's whichever appears first. Whatever occurs first from left to right. Okay, what that means is, like if I have, let's say I have like 24 divided by 3 times 10, something like that. 23 times 10. Now, if you take PEMDAS too literally, you might go, well, I better multiply first. I better multiply before I did division. No. When division and multiplication, multiplication and division are together, you just want to go through this from left to right. That's all you do. So just like you're reading the words on a page. 24 divided by 3 is 8, and 8 times 10 is 80. Okay? That's the only way you can do it. So it's whatever appears first from left to right. The same is true, what I just talked about here, the same is true about addition and subtraction. Which, like there's pushback about the PEMDAS acronym because it's, a little bit misleading. You know what I mean? It's a little bit misleading because it makes people think, oh, I'm better add before I subtract, and that's not true either. Again, I'm just gonna put this example out there. But if you have like 17 minus 6 plus 20, something like that, you've got to, the addition might stand out to you and go, oh, I better do that first. No, when subtraction and addition are together, just go left to right. So the same thing is true about this. I'm going to put ditto for this part right here, which means like same, okay? Same deal. So it's whatever appears first from left to right. Okay, so now that's out of the way. So kind of recap here. So parentheses, the P stands for parentheses, but I'm showing you this. It's like not really helpful, but it is helpful in a way. It kind of helps us understand. But parentheses is really any grouping symbol, not just parentheses. We have all types of grouping symbols. The E stands for exponents. Okay, multiplication and division. Now that's whatever happens first from left to right. And same thing goes for addition and subtraction. Whatever occurs first from left to right, you do it that way. Okay. All right, so for this next part right here, let's kind of tackle some order of operation problems. Now, my advice whenever I teach order of operations to anybody is just to keep in mind that I kind of just think of the tortoise and hare proverb, which is just slow and steady wins the race. Just take your time, do one thing at a time. Try not to do too much at once. Through my experience, those people that try too much, they try to do too many things at once, they end up getting these wrong, or they just they take on too much. But just one thing, one part at a time, rewrite the problem, do another step. Do that step, rewrite the problem again, and just keep doing it. Because just take your time, especially like if you look at example D, that's probably the longest example. That's where you want to take your time. Sometimes I get it. Sometimes people look at them like, oh, I can do the first one in my head. Great, proud of you. But I would just say some of us have different comfort levels with math, and we might want to just take our time. So with example A, let's kind of just do that one. So example A, the first thing we want to do is exponents. That's it. So 2 to the 5th power. 2 to the 5th power. That's not 10. That's 2 times 2 times 2 times 2 times 2, which is 32. Okay? So that is 32. And then everything else drops down. So I'm going to rewrite it. Minus 10 plus 8. Okay? So you got 32 minus 10 plus 8. Now this is what I was just talking about. We have subtraction. We have addition together. So at this point, just do it left to right. So we're going to do 32 minus 10. Why? Because that's what happens first, right? That's what occurs first in the problem. So 32 minus 10 is 22. And then drop down the plus 8. And that should do it, right? 22 plus 8 is 30. Okay, we're done with that one. All right, pretty easy, right? Right there. All right, example B. All right, now example B has got a little bit more going on in it. It's got addition, it's got parentheses, got inside the parentheses has exponents and subtraction. So let's do the parentheses first. Now inside the parentheses, we want to take care of the exponent first. So that's what I'm going to do. So everything else is going to drop down. 5 plus 6. Now 3 to the third power. 3 to the third power is not 9. That's 3 times 3 times 3, which is actually 27. So I'm going to write 27 right here. So you got 27, okay, minus 7, minus 6. Like I said, just doing one thing at a time, I think is a way to kind of approach these problems. All right, so we still have parentheses going on. Let's take care of that. So you got 27 minus 7. Let's do that next. So 27 minus 7. Now, it's also good to keep in mind that there's a 6 next to it. The 6 is right up, it's butted up against the parentheses, which is implying or it's inferring to do, that means multiply 6 by whatever is inside the parentheses. So let's do that. So 27 minus 7 is 20, right? So I'm going to rewrite it. So you got 5 plus 6. And I'm going to write times. I'm going to write times to kind of remember. And we don't need parentheses anymore because 27 minus 7 is 20. And then I'm going to drop down the minus 6. As you can see, one thing at a time. Just do one thing. I'm not trying to take on too much. All right. I think that sometimes a lot of people go wrong on these. They wonder like, why I keep doing it over and over again. I keep getting the wrong answer. But you just got to, sometimes people do order of operations for the first step and they're like, everything else is out the window after that. They do their own order of operations. Now you got to follow order of operations each and every step. Very, very, very important. I can't tell you how important order of operations is. I mean, this is something that happens in all of math, right? It's not just something we talk about in this pre-algebra course and it's never discussed again. It's always present. It's always something that you have to kind of keep in mind. And it's something you just got to keep doing. You got to get good at it. It's very, very important. All right, so we've got multiplication. We're going to do that next. So 6 times 20 is 120. 6 times 20, so I'm going to rewrite it again. So 5 plus, okay, 120 minus 6. All right, and then at this point, just going to go left to right because all it is subtraction, addition, subtraction. So that's what, 125, right? 125, and then you got minus 6. Okay, and that makes, what does that make? 125 minus 6, that makes 2,000. No, it doesn't. That makes 119. That's the answer. Okay. You can see how we did that. It was very organized about the way we did it. I think that's really the approach you want to take with these problems. I know some of them are easier. Like the first one was pretty easy. You can almost look at that and get it, mentally, perhaps, depending on how comfortable you are with numbers, but really just kind of take it that way. C C is what I'll talk about with grouping. Now, a fraction is like parentheses, right? It's just you've got, it's a way of grouping the top and grouping the bottom, the denominator. Okay, so we want to kind of take care of those separately or independently. So we got 17 plus 10 divided by 2. Let's go ahead and solve that. Let's do the division first, right? Do division first. So then you got 17 plus, and then 10 divided by 2 is 5, which is, that's going to be 22, isn't it? Right, now let's hold on to that. Hold on to that, that's 22. Now, the bottom is just 11, right? That's easy. You don't have to really do much with that. And so now let's put it all together. So we have 22 divided by 11, which is 2. What it is. All right, that was a pretty simple one right there. Not a lot to that. All right, now this one right here, D, that's a little bit of a doozy. It's got a lot going on. So we've got parentheses. That's the first thing we should be looking at inside the parentheses. Okay, now take care of this. And so we're going to take care, we can take care of both of these at the same time. We can do those exponents. All right, so we don't want to do the addition, right? Don't want to do any addition or multiplication until we've taken care of those exponents. So within the parentheses, within the grouping symbols themselves, we want to take care of, or we want to follow order of operations, within the parentheses as well. So let's just rewrite it. So you got 63, I'm just dropping everything down, times 4, minus 5, I'm going to keep the parentheses intact for right now. 3 squared is 9. All right, plus 4 times, and then 2 to the third power. 2 to the third power, that means 2 times 2 times 2, which is 8. Which is 8. All right, close the parentheses here. See, that's all we did. I kind of, things get a little bit skewed as we write it, but that's all we did. All right, now we still have parentheses to take care of. Let's keep them up here. So in the parentheses, we want to do the multiplication before we add. So let's do that. So we're going to do 4 times 8, which is 32. So I'm going to rewrite it again. We got 63 times 4 minus 5. Now the 5 is up against parentheses, so we want to multiply, but not yet. Let's just go ahead and leave it. So 9 plus, and then like I said, 4 times 8 is 32. And there you go. So you got 9 plus 32. Now let's go ahead and take care of these parentheses once and for all. We got 9 plus 32. So that is 41. So 63 times 4 minus 5 times, I know there's a 5 here up against parentheses, which is inferring multiplication. So 5 times 41, right? 5 times 41, and then plus 5. Okay, now at this step right here, we've got multiplication, we've got subtraction. Now we've got multiplication going on in 2 different spots. Now we can take care of multiplication here, and we can take care of the multiplication here kind of at the same time, because those don't really affect each other. As long as we do them separately, they don't really affect each other. So you got 63 times 4, which is what? Well, 60 times 4 is 240, right? And 3 times 4 is 12, so that's what, 252? Just kind of doing some mental math there. All right, minus, and then 5 times 40 is 200. What's that, 205? 205 plus, so we got plus and then 5. And then at this point, we're just going left to right. All right, so you got 252 minus 205. And what's that going to be? That's going to be 47, right? So you got 47 plus 5. And then we're all done. 47 plus 5 is going to be 52.